Hey everyone, Professor Michael Scanlon here. I wanted to talk to you today about air. You might be like, okay, what about it? Did you know air has a weight? In fact, it weighs a lot. We tend to ignore this wonderful fluid, this necessary fluid that we live in. I want to show you a couple of ways today that you can see how much air weighs, or the fact that air weighs anything at all. So, I have here an 1/8 inch thick piece of basswood. You can do this with pine. I don't recommend plywood because of how it's constructed. It won't work as well, but it will work. If you're going to duplicate what I'm about to do, please be careful and have adult supervision. That's right. So I'm going to break this board. What's that got to do with air? Well, I'll show you. If I wanted to break the board, I mean, it's thin enough, I could just break it over my knee, right? So another way I could do it is to put it on the table and hold one end down with one hand and whack the other end with my other hand. But what if I don't want to do that? What if I told you there was another way? I have here a sheet of newspaper. I bought it today. It's the Natchitoches Times. And I've placed it on this table. Now, I'm going to take this board, I'm going to slide it under the newspaper, like so. There we go. Until just enough for me to break is actually sticking out. And I'm not going to hold it down. I'm just going to hit it and break it. Are you ready? Well, how is this going to work if you're not holding it down? All you have on it is a piece of newspaper. But is that all I have on top of it? No, I've also got air on top of this thing. Watch what happens. You ready? Here we go. And just like that, we broke the board. How did this happen if I wasn't actually holding it down, doing this? How did this newspaper do that? Well, the newspaper was kind of an intermediary. It was a mediator. It was a go-between. The real culprit and the real thing that held this down was the air. You see, air weighs something, and it exerts something called pressure on you, on everything around us. And it's just under 15 pounds of pressure for every square inch of surface area. You want to be technical about it? It's 14.7 pounds of force for every square inch of surface area. For this sheet of newspaper, I calculated it. It's over 9,000 pounds of air just sitting on top of this newspaper. That's exerting a lot more force than I could to hold this board down and break it. So that's a way to show that air has weight and it actually can do something, not to be taken for granted. Here's a simpler way, I guess you could say a safer way to do this, although if you do that right, it's really safe. I've got, in my case, a meter stick, okay? Any long, thin stick will do. And I've already measured this out. I've already done this to save time in the video, so you didn't have to watch me kind of figuring everything out. I figured out where the midpoint was. Now, I wouldn't recommend dropping it for one, and I wouldn't recommend trying to balance it on your fingers. You're just going to be obstinate, aren't you? I'll put that back on in a second. Here's what I recommend doing. For whatever device you happen to use, don't you just love these videos raw, unedited, full of mistakes? Kind of like science really is. Anyway, find the midpoint, the balance point for whatever it is that you're using, okay? Mine's going to be off a little bit because I've got a balloon over there and nothing over here. But then take a rubber band and put it at that point, like wrap it around wherever that midpoint is, and then take a string and tie it to the rubber band so you can actually hang this thing, and that it would actually just kind of hang like that and balance. It'd be a much better job than anything I'm doing here, trying to balance it on my fingers. Okay. So, are you going to work or are you going to be difficult? It's going to be difficult. What you're going to do is get a couple of balloons and some tape. I'm gonna have to retape mine. You're gonna get a couple of balloons and some tape, and tape the balloons. Let's see. Okay. Tape the balloons to the whatever it is you have. In my case, it's the meter stick. And move them around and figure out where they will go, where the best place for them is, so that the meter stick or whatever it is you're using will balance. Now, stay put. There we go. It should sit pretty evenly. Not very thrilling, is it? Take one of the balloons. I want to take the one I just put on. And here's it right there. Blow it up. Now what did I just do? I put air in this. Not a lot, but I did put air in it. And I'm going to take it and tape it back on its little spot here. I just need you to hold for a little bit. I'm going to put the meter stick back on its balancing point and look at what happens. Is it still balanced? Nope. Why? There's more weight on this side than there's on this side. Where'd the weight come from? It came from the air. This is an easy to do demonstration or experiment. You can change things up. You can change how many balloons you have. You can figure out how big a balloon needs to be to balance some other ones. That's a fun thing to do. You can figure out, does the temperature make a difference? So what do you mean? Well, do this, and then take this balloon and put it in the freezer for a while. What's that going to do? I'll let you see on your own. Once you get it out of the freezer after it's been there for a while, put it back on its spot and see, does it still tilt the same amount? Does it still do the same thing? Is there a difference between the hot air and the cool air? You can do a few different variations on something as simple as this. And that will let you explore air pressure, balancing, a number of different topics. I hope you enjoyed today's video. All of our videos, really. Thanks for tuning in. Thanks for your support. I'll see you soon, everybody. Stay safe.